I just have, hey guys, this one right here, number 5. I just feel like a gut feeling. This is going to be a type of problem that you're going to see. So I don't know. It's super conceptual. Uh, Lots of information you gotta deal with here. It's understanding all the concepts and the different pieces of the puzzle. Uh, so really, the biggest thing that I can tell you guys is on this one you're gonna have to. It's not like a lot of solutions and different things like that. Uh, you use things a little bit differently. So, if we go through this, the biggest thing I want you guys to understand is this is F prime. F prime. That means that F goes the other. We've got to take an integral if we're going to go to F, and then we've got to take the derivative if we're going to go this way. Now, since they don't give us anything, it's a little different. So if we're going to go to F prime, we're going to actually use the slope formula. Okay? And if we're going to go to position, if we're just going to go to F, we're going to use given information, or we're going to have to use area. We're going to have to do a manual calculation because they don't give us anything there, okay? So just know that when we're dealing with this, you got to really pay attention to this. So, like this, the slope at 1 is -4. Excuse me, of the original. So you've got to learn how to read these things. So now we're looking at write an equation for the tangent line at 1. So we want the equation for a tangent line at 1. So that right there is what we're dealing with. And so you're going to go, oh, well, I'm going to use -4. More than likely not, guys. Okay? So we're going to have to really, because it's a write an equation for the graph of G. Remember, G's different. G is this one. All right? So there's a lot of information going on here. So this is the derivative of function G. So you're going to have to utilize things, like I said, a little differently when it comes to this equation. So for this particular one, A, there's not a lot of room, so I'll write A down here. Don't forget that your point of tangency is just going to be a slope equation, okay? So sometimes you've just got to figure out, if you're going to figure out tangent lines, sometimes you just got to go straight to the slope or the rate of change formula. So I'm going to leave you with that one. And then this one also includes the chain rule. This includes the chain rule, especially for something like that right there, okay? So look, that's f of x. They give you f prime of x. So G is related to f prime somehow. So we got to figure that out in the first one. In B, they're talking about local maximum and minimums. So for your local and maximum and minimums, we have to deal with G prime. So we got to figure out what G prime is, because when we're dealing with local maximum and minimums, we need to know and use a sign chart. The sign chart's going to justify your values that you create. So when I see justify, it's pretty easy once you figure out what G prime is. So make sure that you tackle it with a sign chart on that one. C, G prime prime, or G double prime, we're literally looking at this and sliding back down, and we're dealing with concavity and the second derivative test. DER, derivative test. So make sure we're going in that direction on the second derivative test. And then we're dealing with concavity. So you're going to have to look back. Still has to do with sign charts and values of numbers at certain points. Don't let a lot of this junk confuse you, because they're giving you information, but they're really asking, is it positive, negative, or zero? It has to do with concavity and the second derivative test. And so on the last one, part D, Part D, the average rate of change. Average rate of change, guys. That's just literally the definition of a derivative. Okay? So somehow on this interval from 1 to 3, you got to find the average rate of change. And the average rate of change always boils down to back to the definite derivative, and that always boils down to slope. Okay? So hopefully that'll help you guys out, and we'll solve them if we need to. But I will talk to you guys soon.